So we have two functions here, and I will point out one thing, and this is true of a lot of other questions moving forward, is this is a shared point. And that shared point is super important because it's going to help me find out information I need to know about g of x. Let me walk you through this scenario right here. It's asking me in the end, so I'm hoping you read the questions in full on your own. In the end, it's asking me, could the ball have been thrown from a height of at least 2.1 meters? Really, all it's asking is, what is the height of this guy when my y is 0? Or sorry, when my x is 0? Because that's the y-intercept. That's where it's being thrown from, right? So if my objective is to find the height that it was thrown at, let's label the things that I already know. Okay? And I just did that wrong. Maximum height of 2.7 at 0.5 seconds. What did I just do wrong? I just did it wrong. I put the h and k in, but why is it wrong? No, it says for during the first bounce g of x, it's backwards. Height is always going to be my y-axis, and time will always be my x-axis. X is always the independent variable. It has to be, right? Because time cannot stop. It is the one that nothing can impact. We cannot stop time. So that makes this guy 0.5 and 2.7. So I know those things, and I actually already know the rule for this function here, right? So if I start to list out what it is that I know about f of x, I already have the rule. That's like super helpful to me. Okay, so a, h, k, point, z1, z2. I already know the a is negative 0.25. I know the h is positive 4. My k is 1. But I know nothing else about it. Okay? I'm going to, right next to it, put, stop doing that. Okay? G of x. Okay? Let's label what we know about this guy. I don't know what a is. I don't know what h is. I don't know what k, or sorry, I do, but I'll write it down here in a second. Z1, Z2. So the only thing I know about it is this is 0.5 and that's 2.7. Label all your information first out like this, then you'll be able to kind of get started on it. Where this question is tough is now that you have to know that the second zero of g of x, so, right, g of x has a z1 and it has a z2, and f of x has a z1 and a z2. It has two zeros as well. The second zero of g of x is the first zero of f of x. Meaning, if I can find this shared point, I will now actually have a zero. I will have a zero that I can plug into g of x as a point, right? I'm always going to try and work with this guy in vertex form because it's easier, it's better, it's more maneuverable. So just to walk back, this is a shared point between these two functions. It matters that it's shared because as soon as I find it, I can use it for g of x. This is information I did not have before I solved for that zero. So I'll be able to use that zero as a point to find the rule of g of x. Why is it important to find the rule of g of x? Because I want to use that rule to figure out what the y is when x is 0.
So like whenever you get like z1
yeah,
or f of x and stuff, you just automatically put like a 2 and then the 0?
Yeah.
Like it'll always be 0?
Yeah. Yeah. Anytime I find a 0, you're right, the y is always going to be 0. Hence where it gets its name. So my first start would then be to go, okay, well, I obviously need to find that 0, and they've already given me that rule, so that's great. I am going to find zeros of f of x because I need one of them for g of x. So I'm looking for what is x when y What is x when y is 0? I don't have to set this equation to 0. I can literally just use this is a, this is h, and this is k. So I can now plug things in. Find for zeros. Zeros are equal to h plus or minus square root negative k over a. I don't have to modify the AHK. The k is going to stay the same. So it's just going to be 4 plus or minus the square root of negative 1 divided by negative 0.25. 4 plus or minus square root of 4. 4 plus or minus 2. So I'm going to end up with 6 and 0. Well, let's just say 6 and 2. I said I want the first 0, so this is the guy I'm going to accept, meaning of these two zeros, right? 2 and 6, that's the one that I'm going to transfer over to g of x. So I found both this 0 and this 0, but I really only needed that guy there. Now, well, that 2 and 0 is literally just a point on the line. Now I have hk and a point. So I can find rule of g of x using vertex form. A, x minus h squared plus k. I now just plug in everything that I just found. So the 0, the a is unknown, the x is now 2, and then this was what, 0.5? 0.5 squared plus 2.7. So I'm just going to rearrange things again. Where are most people making the mistakes on this guy here? Get that garbage out of here. Get that 2.7 out of there. So negative 2.7 is equal to a 1.5 squared. And then I'm always going to do my 1.5 squared and say negative 2.7 is equal to a 2.25. Now I can just divide. So 2.7 divided by 2.25 gives me something not bad, but negative 1.2. And again, my answer returned me a negative value. If you kind of skip things around here, make sure to always look into that. I'm going to always scroll up and go, or flip up and look at it and say, is that parabola facing down? Yes, it is. So my answer should be negative. It has to be. So now that I found the rule, and so the rule isn't just the A, it's everything. I'm going to write this neater so Brooklyn doesn't make fun of it. And then 0.5 squared plus 2.7. So now I have a rule that I can use. And what is it that I'm looking for now? I'm finally looking for what is the y when my x is 0. So the last step of this is find y when x is equal to 0. Find y when x is equal to 0. So I just plug it in now. Y is equal to, and remember, don't overthink it. A lot of people do this. Their brain turns into mush after going through HK, all that stuff, finding all that. It's now just bed mass. Yeah.
So when you find the y, if it's not like 2.1 meters, like if it's higher than that, then it's like the answer's no.
Because what's the framing of it again? The phrasing is, could it have been thrown from a height of at least 2.1? So it has to be like 2.1 or higher. Because if it had to have been thrown from at least 2.1. So then it would be 2.1 or higher.
Okay.
Yeah. So then y is equal to negative 1.2, 0.5 squared plus 2.7. This is, again, just bed mass, 0.25. 1.2 times. So something ugly like y is equal to negative 0.3 plus 2.7. So the height it returns is 2.4. So in the end, we would say, yes, it was thrown from a height of at least 2.1 because the actual height of it was 2.4. So it does meet those requirements, those conditions that were provided to us.